Hi there. Thanks for joining us yet again on yet another episode of the yet-to-be-heard Space Nuts. My name is Andrew Dunkley, your host, and it's good to have your company. Coming up on this episode, we talked about it before. It was rebuked, debunked, and the door was shut on it, and that was life in the atmosphere of Venus. And we only spoke about it the other day, and yet again, it has made the news. We'll tell you all about it. We're also going to look at some movement on the issue of space debris. You might remember there were a couple of incidents recently with houses hit and people thumped and all sorts of, because of space junk. Well, it looks like they're going to literally move on that issue. And we're going to talk about a man that Fred has worked with in the past, a man who had a wonderful astronomy career, has recently passed, but a real advocate for dark skies, David L. Crawford. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And making his moves in this episode will be Professor Fred Watson. Hello.
Yes, everything in the universe moves, so I might as well move as well, which is great. Good to see you.
Well, you too. I just got back from Sydney. I didn't have time to rush over to your side of the city.
No.
Would have taken way too long.
Hope you do sometime.
Yeah, I would love to. But we were moving our son into a new apartment, and it was. He's very happy. It's a lovely place. It's in a very nice suburb. It's off a main road. In fact, it's nowhere near a main road, so it's really quiet. He's done well. I'm very proud of him, and we both are. And it all went well until I stubbed my toe on a concrete step, and I just hit it at the perfect angle to cause mayhem and destruction. So ended up in a doctor's surgery and had to have the pressure relieved by drilling a needle through the top of the nail. I don't recommend it.
No. Did you get any kind of local anaesthetic for that, or did they just cover it in?
No.
Yeah.
No, he just we actually, it was funny because we were having a really long conversation while he was doing it. I think it was more for me to keep his mind off it than mine, because I didn't really care. I've had so many needles stuck in me over my life.
I suppose that's true.
Just another one. I must say he was very good. It didn't hurt at all. So
excellent.
There was already a lot of pain there, so maybe it did. And I didn't notice, but it just completely, just have been the perfect angle to cause the damage, because I had shoes on, but still, I won't show it to you. You don't.
No,
nah.
Thank you. It's very kind of you.
No. But it's that colour.
Oh gosh, yes, I can imagine.
Black
Sounds
and blue.
like a freak accident, though, and one that you could have done without, probably. Was that before or after you moved all the furniture?
It was in the middle of
Okay.
all that. We didn't have to move the big stuff, but lots and lots of boxes full of, bits and pieces. So it was very difficult. But anyway, it's done. He's happy. We're all happy. I'm home and on the mend. I hope you haven't had any incidents of...
No, so far it's all been smooth sailing, and let's hope it continues that way.
Yes. All right, we better get down to business now. We did only a week or two ago talk about this supposed discovery of phosphine in the atmosphere of Venus, which the discoverers suggested could mean signs of life. But then that was debunked. And it's sort of been going backwards and forwards for the last, as it turns out, 4 years. 4 years since that discovery.
It's amazing, isn't it? Yeah.
And now it's back to theory number one, because the people who made that discovery have gone back to their original concept with a new sort of element to add to the argument. So they're again saying it is phosphine, and we are going to stand by this discovery.
That's correct. And I think that this time it might stink, Andrew. I think it might be one that is much harder to refute by not the naysayers, just the skeptics, the people who, as we all do in the world of science, think, well, is that really correct? So yes, that discovery made back in 2020, the same team, basically, and that team includes a really good friend of mine on the island of Hawaii in Hilo. And in fact, that's where the telescope is, and that's why he's there. The telescope is called the James Clerk Maxwell Telescope. It's not at Hilo; it's on the summit of Mauna Kea, which is the mountain that really makes up, along with Mauna Loa, the bulk of the big island of Hawaii. As you know, one of the best observing sites in the world for Northern Hemisphere astronomy. The James Clerk Maxwell Telescope itself, quite a well-established and old facility. And unlike some of the other ones, which sit right on top of the mountain, where you can see them from all over the island, and that causes all kinds of grief, which is quite understandable. The JCMT is nestled in a valley on top of the summit. There are valleys up there. It's quite an interesting geography. And that's to keep it away from terrestrial microwave radiation, because the James Clerk Maxwell Telescope is a microwave telescope. So once again, this team has pointed their telescope at the planet Venus, but this time they have a new receiver on the telescope. And that apparently is the game changer in this work. It's certainly giving them a good deal more confidence in the results that are coming out of it, and much more of the data themselves. Basically, and the bottom line is that in each of the 3 observing campaigns they've done with the James Clerk Maxwell Telescope, they've got 140 times more data than they did with the original detection. So that's why they are much more confident in their results. This is a quote from Dave Clements, who's a reader in astrophysics at Imperial College in London and one of the team members. What we've got so far indicates that we once again have phosphine detections. And so that's, it's a bold thing to do, to go back to your original target, knowing perhaps that you've got a better instrument, and have another look. And it looks as though they are much more confident. But there's also, but wait, there's more story, because there is more to this. There is another observing team, which is working on a different part of the microwave spectrum, and they think they've detected the gas ammonia. And that apparently is basically, an even bigger puzzle. So, quoting Dave Clements again, he said, that is arguably more significant than the discovery of phosphine. We're a long way from saying this, but he's saying it anyway. We're a long way from saying this. But if there is life on Venus producing phosphine, we have no idea why it's producing it. However, if there is life on Venus producing ammonia, we do have an idea why it might want to breathe ammonia. And that is the interesting part of this. And just to elaborate again, another comment from Dave Clements, phosphine has been discovered in the atmosphere of Saturn, but that's not unexpected, because Saturn is a gas giant, and there's an awful lot of hydrogen in its atmosphere. So any hydrogen-based compounds like phosphine or ammonia are what dominate there. But the same is not true of rocky planets like our own, and Venus and Mars. And that's why, the possible detection of these hydrogen-based compounds, phosphine and ammonia, are so unexpected on Venus.
Well, it does open up a can of worms, and it could be worms, I'm not sure. But what are the odds of it being life? I know they say they're a long way from saying it is, but it could be? Or, well, I suppose the alternative question, what else could be causing the existence of phosphine and ammonia?
That's the right way to look at it. He's very, Dave Clements is certainly talking the talk and giving us some very good quotes here. Phosphine and ammonia have both been suggested as biomarkers, including on exoplanets. So finding them in the atmosphere of Venus is interesting on that basis as well. When we published the phosphine findings in 2020, quite understandably, that was a surprise. And so he makes the point that other instruments have not actually made that detection. And they include the Venus Express spacecraft, which is an ESA spacecraft in orbit around Venus. They include and something called the IRTF, which is a NASA facility, again on Hawaii, not actually very far from the James Clerk Maxwell Telescope, NASA Infrared Telescope facility. And observations made with actually an observatory that another of my friends has worked on, SOFIA, which was the airborne NASA observatory on that 747 SP, with a big hole in the back of it. That's now no longer flying. But that, when it was, and also obviously observed Venus, and they didn't find these phosphine findings. So there's a number of different investigations that have not turned up the gas phosphine. And I am getting to the answer to your question in a minute, Andrew. I'm working round to it. But they've ruled out one of the things that was suggested as being a contaminant when that first lot of phosphine observations were released, and that was sulfur dioxide. And that is basically ruled out now by the Atacama Large Millimeter Submillimeter Array, ALMA. But the key thing here, and again, I'm going to quote Dave Clements, it turns out that all our observations that detected phosphine were taken as the atmosphere of Venus moved from night into day. And all the observations that didn't find phosphine were taken as the atmosphere moved from day to night. And the suggestion is that the ultraviolet light from the sun actually breaks up these molecules as it moves from day into night. So, if you take them at the end of the day, the molecules have all gone because the sun's basically baked it out, as Dave Clements puts it. All phosphine is baked out, and that's why you don't see it.
Okay.
Yeah. So that suggests that the phosphine observations might be real, and they might be sort of being replenished, if I can put it that way. Because if you've got phosphine that at the end of the day isn't there, it's been baked out, but at the beginning of the day it is there, it suggests that something is forming phosphine, and maybe that is an indicator of life.
Yeah, you've got to wonder what kind of life that could be. And it would be residing in the upper atmosphere because it's too hot for anything down on the planet.
That's correct. And there's nasty things as well. There's all the sulfuric acid at lower levels in the down in the droplets cloud, the clouds of Venus further down. So look, it's what they're suggesting, and this now is a quote from actually once again from Dave Clements. I thought we were going to get another voice, but ammonia. Actually, let me quote Jade Greaves is Professor of Astronomy at Cardiff University, and actually I think she's the leader of the team. She says the exciting thing behind this will be if it's some kind of microbial life making the ammonia, because that will be a neat way for it to regulate its own environment. It's really interesting that they are so confident with these observations. They're actually trying to look at what mechanisms living organisms might be using to create the phosphine or the ammonia. So I think they'd put it at 50-50. I'm just reading between the lines here. Myself, I'd put it lower. I think that maybe, we've barked up this tree so many times, Andrew, looking for rock solid biomarkers, and they're very, very difficult to find. Even if you find something that you think is only caused by living organisms, there's probably always going to be another chemical way, purely chemical way, that you might form it, and that might not have been found yet.
Right. So it could just be some kind of chemical reaction unique to Venus.
Maybe so, caused by just the unusual conditions in the upper atmosphere. Yeah.
Yeah, well, they certainly are unusual, although we're really working hard to get there ourselves, aren't we? It's, yes. It's a great story. Hopefully they're right about the phosphine and the ammonia, and hopefully, and they're not absolutely saying that it's caused by life, but, let's hope it's true. It would be wonderful to discover life beyond Earth, as and our focus is on Mars and Enceladus and, ice moons in general, but Venus certainly sounds like it's a candidate worthy of further investigation. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson there.
3, 2, 1.
Space Nuts.
Now to another thing in astronomy and space science that keeps popping up in the news, that of space debris. And there's been plenty of debris hitting the ground in recent times, and it's starting to become a real concern. There have been incidents around Florida. There's been incidents in Australia. It's happening in several places. And this is because we're seeing so very many launches around the world, and Florida's been a bit of a hotbed of space launches in recent times. But that incident we talked about a few weeks ago has it sounds like it's sort of become the straw that's broken the camel's back in certain respects, Fred.
I think that's correct. Yes, the bit of debris that came through somebody's roof in Florida, because no space launch organization wants to be responsible for something coming back and injuring or killing somebody. Now, that's not happened yet, but they're worried that it will. But this is a little bit more specific than just the very large numbers of spacecraft that are being launched. It's to do entirely with the Dragon space capsules, which are a product of SpaceX. They are flown on SpaceX rockets, they're Falcon 9 rockets. And the Dragon capsules come in two flavors. One is Crew Dragon, which has humans on board, and the other is the Dragon, which doesn't, which is a cargo spacecraft. So there are two different kinds, and they've been significant numbers of both, actually, which have flown. In fact, if I'll find it. There have been, I can't remember how many of the Crew Dragon missions have been, several, but there have been more than 20 of the Cargo Dragon missions. So you can see, we make the Crew Dragon missions tend to make big news because they're carrying astronauts. The Cargo Dragon ones don't, and there are far more of them. They're the ones that dock remotely with or autonomously with the International Space Station, and sure enough, they unload cargo. And that's great. So the Dragons, there are more of them than we tend to hear about, is what I'm getting at. But both of them, both the Crew Dragon and the Cargo Dragon capsules, have what is called the trunk, and that is it's basically it's what we used to call the service module in the Apollo era, and in fact I think Boeing still call it the service module for their Starliner spacecraft. But the trunk component, so it's a cylindrical space vehicle which sits between the capsule itself, carrying either crew or cargo, and the launch vehicle. And I think it probably is the second stage of the launch vehicle that it sits on top of. So that trunk is the bit that is the culprit here, because it's bits of those trunks that have fallen in various different places, including Australia, not very far from Canberra, including the one that went through the roof in Florida, including North Carolina and Saskatchewan in Canada. All of these places have had bits of SpaceX Dragon trunks falling on them. And so SpaceX have gone back to the drawing board to look at why this is happening and to try and understand how it can be prevented. And there are two things I think that have changed. One is that they have changed the landings of the Dragon spacecraft from the east coast off Florida to the west coast of the United States. So that they will start landing the Dragon capsules themselves in the Pacific rather than the Atlantic. In fact, they're basing their operations out of Long Beach, California, for their what's called post-flight processing. In other words, going and recovering the Dragon capsules, and then they will be transported across country back to Florida for the next launch. So that's one thing that they've done, and the other is that
that's a big thing, though. That's not going to be a cheap move.
Huge, that's right. It's going to cost them because they're not just pulling these things out of the water right next door to where they're going to launch it the next time. It's got to go across country. So yes, it will cost them. But the other thing is that they'll shift the time that the re-entry burn starts, because I think, if I'm remembering this correctly, the situation has been that they have separated the Crew Dragon capsule from the trunk before they have fired the trunk burn to bring it back. And I think they're going to do that afterwards now. I hope I've got that the right way around. But the bottom line, we're not flying the spacecraft, so it doesn't really matter. But it's a change in the way that they will actually initiate the re-entry of the trunk. And the hope there is that it will achieve high enough velocities to burn up completely. But if it doesn't, it will fall in a much more safe zone. It's much likelier to fall over ocean than over land. That's the bottom line.
Right. Well, it's good that they've taken notice of the problem and they're making moves to reduce the potential impact. So that'll come as a relief to a lot of people and probably insurance companies too. I mean, it sounds funny, but they've been talking about it becoming a thing for homeowners and business owners in certain parts of the world that have a lot of these potential problems. That could jack up premiums, and it also reduces the risk to human life, which is the most important thing. So it does sound like they're making some positive moves, Fred.
Yes, that's right. I think it's a good outcome, and let's see what happens. Let's see how it goes. Yeah.
Yes. If you'd like to read up on that story, it's available on phys.org.
This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
One more thing before we wrap it up, Fred, and a little bit of sad news. David L. Crawford, passed away just in the last couple of weeks at the age of 93. This is a fellow who has worked had a very long and wonderful career in astronomy, and I believe you've crossed paths with David in your career as well.
Yes, indeed, that's right. So actually, there's a very nice tribute to David Crawford on the Sky Telescope website. Just the first paragraph of that says it all. With the peaceful passing of David L. Crawford on July the 22nd, at the age of 93, we've lost the person who taught the world about light pollution and warned us all of the threat it poses, not just to astronomy, but to the entire nocturnal environment. So he basically spent time at major observatories in the United States. He was an astronomer, exactly as you've said. He got his doctorate from the University of Chicago, spent time at Yerkes Observatory, and basically wound up in Tucson, Arizona, at the Kitt Peak National Observatory, which is the equivalent of Siding Spring in the United States, Andrew, to put it in context of our national observatory here in northwestern New South Wales. Kitt Peak, not very far from Tucson, and basically he was really interested in the structure of and evolution of star clusters and galaxies. Absolutely, front rank astronomy problems back in 1960 when he joined the staff at Kitt Peak. And in fact, he basically morphed from those studies into the two great 4-meter telescopes that were being built in the 1960s and early 70s. And in fact, our Anglo-Australian telescope, which was commissioned exactly 50 years ago, 1974, that telescope was a copy of, at some level, a general copy in design of the two 4 meters that Dave Crawford was responsible for, one at Kitt Peak, that's called the Mail Telescope, and the other at the Cerro Tololo Inter-American Observatory in Chile, which is down not far from La Serena, if I remember rightly. So these two big telescopes focused his mind and attention on what could stop observatories, and he very quickly realized that 100 kilometers from Kitt Peak, there was Tucson with 500,000 people at that time, and that it was a city that was getting brighter and brighter, and that was a threat to the environment of the telescopes. But he basically went on a mission to encourage the city to think about this, and they very quickly enacted legislation to protect the darkness of Kitt Peak, and that's where it all started.
Right.
So along with a gentleman called Tim Hunter, who was an amateur astronomer who'd also been concerned with that. So that was the start of the dark sky movement in the world, during the 1980s in particular. Now, I met Dave when he came here for a dark sky conference to Australia. It would have been probably 20 years ago. I met him through another really good friend, a colleague, sadly, who also is no longer with us, Reg Wilson. He was Mr. Dark Skies in Australia. He used to carry around with him a newspaper cutting from 1973, which said, "Now it's light pollution." And it was quoting him, who, having worked with Dave Crawford, knew what light pollution was all about, and that it was not just bad for astronomers, but bad in general.
Yes, it is, because it's bad for human health, exposure to light. We need darkness to get a decent night's sleep, basically.
That's correct. That's absolutely right. So it's all about circadian rhythms. And I've had my other half, Marnie, as you know, she's talked about this on Space Nuts. She's getting to be a world authority on this as we speak. In fact, she's doing a lot of radio interviews because National Science Week here in Australia next week, as we speak today, that will feature dark light pollution as its focus. So it's become much more widely understood than it was before. We now know as well that nocturnal animals and even some non-nocturnal species are badly affected by light pollution. So we know much more about it. The International Dark Sky Association was formed in 1988, and actually there's a quote from the May 1988 issue of Sky and Telescope that reported on that formation. It's now called Dark Sky International, but it was then the International Dark Sky Association. Dave Crawford said, "Lack of awareness rather than resistance to change is generally the biggest problem in controlling light pollution," and I think that remains the case today. I think it's just people are ignorant of what it's all about.
Yes, and they need to be educated, and the torch continues to be held by your good wife Marnie and many other people around the world. But it all started with this great man, and David L. Crawford, who has passed away. Fred, we're going to end on that note. Thank you very much.
Always a pleasure, Andrew, and we'll talk again soon, I hope.
Yeah, like could be a few minutes. Has that joke run out of puff yet? I don't know, but
That's
you
funny.
keep telling it.
I didn't think it was a joke. I just thought it was what we do next.
Absolute reality, yes. All right, Fred, we'll see you soon. And don't forget, by the way, if you are on social media, you can watch us on YouTube, and don't forget to subscribe. You can talk to other Space Nuts listeners via our Space Nuts podcast group Facebook page, or our other Facebook page, which is the Genuine Article. But yeah, they both get plenty of traffic. We're on Instagram, we're everywhere, and we'll be back here very, very soon with another episode. Oh, and thanks to Hugh in the studio for reasons I'm still to glean. But thank you, Hugh. And from me, Andrew Dunkley, thanks for your company. See you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.